Hello students, as discussed in the previous class, in this class we will discuss some application of definite integral. We have already discussed the application of indefinite integral. Now definite integral is also a very important aspect while solving the problem, especially in mechanics. So here I will be mainly focused on the topics of mechanics where application of definite integrals are very important. So let us start from a very basic definition of velocity or acceleration rather. So the acceleration is defined, this we have already discussed, dv by dt, and this we have solved some question based on the application of differentiation. Now if I want to calculate the change in velocity and acceleration in a given condition is given, and the acceleration is a variable quantity which is a function of time, then what we can do to calculate the change in velocity? So to calculate change in velocity, that is delta v, here we will integrate this function of velocity d v here, and since the acceleration is given as a function of time, so this will be the value of change in velocity. Let us say the time initial is given 0 and the final time is given t. So using this limit from 0 to t, we can calculate the value of integral function as we have learned in the previous class, that was detailedly discussed by Subbu sir.
So, is there similar situation where we are integrating to get some other quantity as we are getting velocity from acceleration?
Yes.
Is there some other relation also?
Basically in physics, especially in mechanics, here we are discussing mainly about mechanics. So in mechanics there are various functions which can be calculated by the help of definite integral, and one such quantity is change in linear momentum. So from Newton's second law, you know that F, that is force, is given by rate of change of momentum. So using this relation, we can also calculate change in momentum if force is given as a function of time, that is force is a variable quantity. And that change in momentum, that is integral of f dt, is also called impulse. So impulse, which is written by J, can be written as integral of f dt. And if force is given as a function of time, and I would like to take an example where force as a function of time is given, and using that we can integrate this function and we will get the change in linear momentum. The integration is similar to what we have discussed in the case of change in velocity here. So let us take an value of force F that is given as, let us say, 2t square, and we are integrating this function from 0 to 3. So after integrating this function, what we will get is linear impulse or change in momentum. I would like to invite Subbu sir to solve this equation and describe you how definite integral will help to calculate this function here.
Okay. So if we want to get impulse, right? This is the impulse, which is actually the change in momentum.
Linear momentum.
Linear momentum. So this impulse can be written as 0 to 3, the limits are, and force is 2t square dt. So this would become, after you take 2 as a common quantity because it is a constant, and integration of t square will be t cube upon 3. So I think it is very good here to see numbers after so many variables, because we generally don't understand unless we get some values.
Yeah.
So the limit is 0 to 3. So this will become 2, and when we put the limit 3 cube by 3 minus 0, that would be obviously 0. So you will get 2 into 9, which is 18. So this is the impulse, the
Linear
value
impulse.
of linear impulse.
And you can see that how this definite integral is very important while calculating various quantity, and these are just some example. You also have heard about work done. Now work done, as we have learned earlier, is simply force into displacement, but that formula is valid only when force is constant. Now what will happen when the force is a variable quantity or the force is varying with the position of the particle. In that case, the only method to calculate the work done is by using the method of definite integration, and the formula to calculate work done is very simple. Basically, work done, if the force is a given constant, then work done is simply F into delta x, where F is the force and delta x is the displacement. But when force is variable, then work done is F into dx. Let us say from number A to B, A is the lower limit of position x and B is the upper limit of position x. So here the total work done is calculated by the method of definite integral.
So
Again,
if I remember, not related to the formula but just as a common knowledge, the force which is acting on a body is basically producing some displacement. And the work done by that force is being calculated.
Yes.
So if there is a displacement due to some other force, that is not taken into account.
यहाँ पे force और displacement इस force के कारण displacement है. This displacement is because of the force F applied on a particle, and dx here is the smaller displacement. In this case, this is the total displacement of the particle. Now, if a force is given as a function of x, let us say a force F is given by, let us say, 2x cube, where x is the position of the particle from a given reference point. And if we want to calculate the total work done when the particle is being displaced from 0 to 4, that is value of x is varying from 0 to 4, then what will be the amount of work done, and that work done can be calculated only using the formula of integration. Here I would again like to invite Subbu sir to solve and will describe you what will be the value of the work done by this method.
Okay. So basically, again we have to do a similar calculation here. Earlier the variable of integration was t, now the variable of integration is x. So the work done is 0 to 4. We can take some unit also, like meter, 0 meter and meter. 4 meter. And let us take force is equal to 2x cube, and you can take the unit of force as Newton also to make it more comprehensible, and dx is here, so this will become Newton meter.
Yeah, it is joule.
Which is joule.
Simply you can write joule also.
Joule also. Newton meter is joule. So dx is having meter and 2x cube, which is the force, is Newton. Now if you will integrate it, to x to the power 4 upon 4 will be the integration of x cube, and 0 to 4, this will be the limit. And if we see here that the values of the upper limit is 4 and the lower limit is 0, so in that situation you will get 4 to the power 4 minus 0 to the power 4 upon 4. So this will become 2 into 4 cube, which is actually 64 into 2, 128 joule. This is the force, this is the
Total work done
Total
during this force,
because of this force.
So here we have seen various applications. There are a lot more number of applications of definite integral, and one last application of integration that I am going to discuss in this class. Some other application we will discuss when we discuss the physics part in detail.